Surface area and volume. Some of you have studied from grade 9, some of you have not studied with me, but the idea is you will not get now one type of a shape or a figure, you will be getting a composite shape or a figure. Now, before proceeding to composite shapes and figures, let us understand some basic things where you will go, where you'll do like idiotic mistakes, right? So there is a concept called 1D, there is a concept called 2D, and there is a concept called 3D. When you are dealing with 1D, you are dealing with only one measurement. In such problems, your answer will come only unit. Unit means your answer can be a mm, can be a cm, or can be a m. Have you understood? Example of 1Ds are length, perimeter. You are actually, what you will say, sir, in perimeter I am moving in 2 dimension. No, ultimately you open it up, it's one length. Okay? So all type of perimeters and other things that you do, perimeter is a 1D measurement. Okay, then comes 2D measurement. 2D measurements will always end in unit square, so it will be either mm square, cm square, meter square, and everything that you see as area, surface area is area of a surface, those will come under 2D. 3D comes with unit cube. So here our answers will be mm cube, cm cube, meter cube, and we would be dealing with something called volume. Now the meaning of the word and difference between the terms volume and capacity, right? Capacity is when you talk about storage of any, the bottle's capacity is 1 liter, and I can pour water maximum of 1 liter volume in it. So the capacity of my fuel tank of my car is 45 liters. Right now the volume of fuel that is there in my car is 20 liters. Have you understood? Volume can never overstep capacity. Clear? Okay. Then the next problem that I see children facing here are conversions. Let's get our basics of conversions clear first. First, let's see the conversion chart. The conversion chart starts milli, centi, deci, and after that I'm writing in capital C, gram, meter, right, liter, then I'm writing on top deca, hectare, and then kilo. At your level, this much is sufficient. Milli, centi, decigram. Okay, every place to every place is a 10 gap. 10 of millimeters makes you 1 centimeters, 10 of centis make 1 deci, 10 of decis will make 1 gram or 1 meter or 1 liter, right? After that comes 10 of these will make 1 deca, 10 of this will make 1 hectare, and 10 of this will make a kilo. So when you're moving from gram to kilogram, you're actually moving 1000, meters to kilometers 1000, and when you're moving from meters to millimeters, you are going back 1000. Is this understood? Okay. Then comes the common thing, centimeter cube and meter cube, or vice versa. How to actually do it if we forget in the exam. Now say 1 meter cube, baby steps. 1 meter cube is a 1 meter multiplied with a 1 meter multiplied with a 1 meter. M to the power 1, m to the power 1, m to the power 1. So 1 plus 1 plus 1, 3. Clear? Every such meter I can write as 100 centimeter, 100 centimeter, and 100 centimeter, which means I get 100, 100, 100. So it will be 10 to the power 6 centimeter cube. So 1 meter cube is 10 to the power 6 centimeter cube. If you forget an exam, so 1 centimeter cube should be 1 by 10 to the power 6 meter cube. Clear? Very good. Then comes another unit which will eat your head a lot, and that unit is known as liter. So let's see what is liters definition. Okay, like liquids can be measured in cm cube, meter cube, also in liter. A liter is a typical Indian measurement. So let's understand what is a liter. A liter is actually, and so you'll never forget in your life. So how to remember? A liter is the volume. A liter is the volume of a, what do you call, cube. A liter is the volume of a cube whose each edge is 1 decimeter. That is the easiest way to understand liter. Okay, and then you'll never forget in life. A liter is the volume of a cube whose each edge is 1 decimeter, right? So 1 liter must be equal to the volume of this cube, which is 1 dm, 1 dm into 1 dm. Clear? 1 dm, 1 dm, 1 dm. And each dm can be written as 10 cm, 10 cm, and 10 cm based on this particular chart that we did. So we find a liter is equal to 1000 cm cube. A liter is equal to, in grade 11 chemistry, you'll use it left, right, center. 1 liter is 1000 cm cube. The most beautiful thing comes out here when we see 1 meter cube, 10 to the power 6. So I can write it as 10 to the power 3 again into 10 to the power 3 cm cube. So I can basically write it as 10 to the power 3 liters. Did you understand this or not? This is very stylish. 1 meter cube is 10 to the power 6, of which you keep 10 to the power 3 cm cube, which is actually 1 liter. So what does this actually mean? It means, and see the beauty, if you have a cube whose every edge is 1 meter. Sir, what is 1 meter? When I go to the Reed and Taylor shop, the suitings and shirtings are measured by a stick which is 1 meter. All of us have seen. Now imagine a cube of that size. In that, I can empty 1000 dining table water bottles out there. That is what it is saying. Imagine a cube. Better fan chala lo na. Press the button. Okay. Imagine a cube whose edge is that of a 1 meter. 1 meter stick you must have seen. If you have not seen, then you are very ill-fated child. That only I can say. I hope after saying this, everyone will say, I have seen 1 meter stick. Agar aapne nahi dekha hai, then welcome another Gen Z. 1 meter is what you see in a cloth shop, or the flexible tape which we use for all our stitching, and tailors have it. 1 meter. 1 meter edge cube, you try to think. How big is it? And if you still don't understand what is 1 meter, a meter is this much. This is 1 meter. Think of a cube of this size. In this cube, how many water bottles you can empty? 1000 water bottles, provided each water bottle is 1 liter. That is the finding, na? 1 meter cube is equal to 10 to the power 3 liters. So 1000 liters. 1 meter cube is 1000 liters. Anyone has any other confusion with conversion? Because here you will be, your vehicle will bulldoze. Keep your conversion concepts absolutely clear. Are you fine on these conversions? Centimeter to meter you should be knowing, and use as much as exponents as you can. Your job becomes easier, and nobody is going to mark you wrong because you wrote 3.8 and somebody wrote 3.7. उसमें marks नहीं जाता है. Some more concepts. चलिए. Let's go to some more concepts, and let's start with typically our what you call shapes, our 3D shapes, and let's get an idea about it. So let's take a rectangle. What happened? Let's take a rectangle and let's fill up the edges of this rectangle. This is your shoebox, and you now have measurements which are the width of the rectangle, which is also called the breadth of the rectangle, the length of the rectangle, as well as the height of the rectangle. Okay, height of the rectangle. Now try and see one aspect. Have you seen a Xerox paper bundle? the new pack which you get, that is a cuboid. That's a cuboid, right? So if you see that cuboid, what does it contain? It contains some one ream of 500 or 1000 Xerox papers. So right at the bottom, what do I have? I have a Xerox paper which is, does it have any height? The Xerox, one single Xerox sheet, does it have any height? It doesn't have any height. So what do I have? I have a rectangle. Listen to what I'm trying to say. I have a rectangle which is a lubber, L into B. Another Xerox paper, another Xerox paper, another Xerox paper. How many Xerox papers? H Xerox papers. So it becomes LBH. That is how the volume comes up. Or else if I see from this side, suppose there were greetings cards which were packed in this manner, then I have a BH, 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 BH. How many BH? LBH. Which brings us one more nice thing to understand out here. Wait, 1 minute. So let's say you take a samurai sword and you exactly what you do, you take a samurai sword and say suppose you take out a section view like this. Section view means what, beta? Imagine that this is your what you call vanilla ice cream brick that you have bought, and you have sliced the ice cream brick along the length, and you try to see it from the top. What do you see? You see a rectangle. You see a rectangle, right? So that rectangle will be known as what is known as the cross-sectional area. Cross-sectional area. Did you understand what I tried to say? Take an ice cream brick and chop the ice cream brick along the length. As you see from the top, what do you see? You see the rectangle. Now cross-sectional area multiplied with perpendicular height will always give me volume for any symmetric 3D object. ये ले लो, मतलब ये truth है. Remember this always. This will help you get all answers correctly. Cross-sectional area multiplied by the perpendicular height. Now, how did I cut the ice cream brick? I sliced the ice cream brick like this. So the perpendicular height is in this way. But if generally ice creams, we will never cut like that. When we bring ice creams, we'll be slicing in this way. So when you slice in this way and you look it from the side, what do you see? You see a BH. A BH with its perpendicular L. So it gives you what? The volume. Have you understood this logic or not? Right. So let's talk about the surface area. So if I look at the surface area of a particular cuboid, I basically have a front and a rear. So I can say both are same. So I have two fronts. Two fronts. Do you agree or not? Shoebox le lo. One this side, one the other side. Then like a dholki, na din din na. I have got two rights. You can write two lefts also. And then I also have two bottoms. Right? This is exactly my surface area. Nothing more than that. The two fronts are what? The L into H. Laha 2. So I can take my 2 common. It's a laha plus 2 rights. Baha. And then 2 bottoms. Laba. This is my surface area of a cuboid. Clear हो रहा है तो? आप भूल नहीं सकते हो फिर. This is my surface area. Now, it will be horses for courses. Say suppose you are designing a dustbin or a trash bin, then the top is not there, mind you. In that you will be having 2 fronts, 2 sides, but only 1 bottom. Or someone tells you that a room is cuboidal and you're whitewashing it. So we usually whitewash the ceiling and the walls, you don't whitewash the floor. So you leave one, right? Or if the ceiling is not there, so you have to have your mind working in that. When we talk about lateral surface area is just like that Hindu mythology devotee. You just go around the temple like this, na? So that is your lateral surface area. So what all are you encountering? 2 bottoms? No. You are encountering 2 rights and 2 fronts. Clear? That is called a lateral surface area. So if this is my cuboid, the lateral surface area is this. Understood? Now, say suppose, okay, slowly we will go into it. So if is cuboid clear? Okay, cuboid has a very cute cousin of it, which is known as a cube. And in cube, the la equals to the ba equals to the ha and is equal to sa. Yes, in a cube, the la ba ha are all equal, and the la ba ha becomes sa. Kya hua, Shreya? All okay? Suddenly you became very serious. Is this okay? The la ba ha becomes sa. See, you drank coffee today. Your friend Ali is drinking coffee. Now he will also not get girlfriend. More caffeine, no girlfriend. So volume becomes what? Volume is la ba ha. So it will be s cube. Volume becomes la ba ha. So it becomes s cube. And if you see the surface area of a cube, every side is goddamn a square, which are all congruent squares. So if I see the surface area of a cube, it is basically a s square top and bottom, s square. So 2s square basically, top and bottom, then 2s square fronts and 2s square rights. So it's a 6s square. It comes from here itself. Everything is a s square, s square, s square, 3s square multiplied by 2, 6s square. Clear? Cuboid clear हो गया? Right now it is going like this. पिछले episode में आपने देखा. So that part of the class is going on. It's all previous episode stories. Cuboid gone. Shall we? Yeah. Our next starts with right circular cylinder. What beta? A right circular cylinder. So let's do a right circular cylinder. A right circular cylinder. So a cylinder actually is, if you go by perfect engineering drawing, then the cylinder will be like this. You have one axis, one Christ at the top, one Christ at the bottom. All right. And then you will make this and you do this. All right. And then this is called a right circular cylinder because the axes are actually at right angles to each other. Is it a symmetric object? Exactly. ऐसे भी काटोगे तो same type दिखेगा. If you cut this also same type. That means perpendicular into cross-sectional area into perpendicular height is applicable here also. Right? A cylinder has the measurements which are given by the height of the cylinder and the radius of the cylinder. Height of the cylinder and radius of the cylinder. Got it? How many of you have seen CD and DVD? So CD, DVD, when you buy in stack, you actually get CD, DVD stack. So we'll use that funda. So if you see from the top, it is one CD. One CD's area is how much? Cross section. Means if I cut it, just take a samurai sword and chop it off. Right? So if you chop it, you are actually making what? Salads. Cucumber, 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 cucumber. Each cucumber is a circle. So each circle is cross-sectional area is how much beta? Pi r square. And how many such? H such. So the volume is pi r square into H. And this also supports cross-sectional area into perpendicular height. Cross-sectional area into perpendicular height. The cross-sectional area has to be constant. See, you could have also said, sir, have you seen when you make noodles and all, how do you chop carrots? You'll be chopping the carrots on the length, and then again on another axis you'll chop them so that you get juliens of carrot. But when you chop it on this side, each chopping will not be of the same size. So the cross-sectional area's uniformity is defeated. So you're not allowed to do it this way. You have to go by kira, 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 or carom board. Coin, 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 coin. How many coins? H coin. And that's your volume. Okay? नहीं भूलेंगे? Aye. बहुत अच्छी बात है. Now think that this is your divine deity and you go around it. So it will be your lateral surface area or curved surface area. This child is just crying out of this. This is tantrum crying. You know that? She's just testing her mother or father's how much they can bend. Curved surface area, CSA, or we call it as lateral surface area. Now wait. Curved surface area. So for curved surface area, you have to think it in this manner. Take the wrist of a newlywed bride, She has lot of chura. So each bangle is what? 2 pi r. I'm only worried about the surface. So each bangle is 2 pi r. 2 pi r, 2 pi r, 2 pi r, 2 pi r. How many 2 pi r? H 2 pi r. Very good. So you understood. Curved surface area is chura into height. So this is 2 pi r into h. Children, if you see this part, this is a circle. So a circle, when you see the area in terms of diameter, then it is pi d square by 4. When we go to engineering, then no more r is said. In engineering, mechanical, everything is in diameter, shaft dia, bolt dia, nut dia. So for us, area is always pi d square by 4. But in school days, what we do? Pi r square, pi d square by 4. Have you understood lateral surface area? So this is my lateral surface area. Now when I do my TSA, so what I have to do? I will take my 2 pi RH, but 2 pi RH is like this, see? Twee, like magician. So I have to close it from bottom and top. So from the bottom, I close it as pi r square. From the top, I close it again as pi r square. So this becomes 2 pi r square plus 2 pi RH. So from here, you take 2 pi r and then it becomes h plus r. This is what you will be actually, this is the one that you always do. Mittu tota. Rattu tota. 2 pi r into h plus r. 2 pi r into h plus r. Nothing like that. First you make chura into h. Then that is twee. Now if you want to make a trash can, if you make a trash can, it is 2 pi RH plus pi r square. Trash can with a lid, then pi r square also comes out. You understood? Very good. Okay. Now, since we have seen volume and surface area, let us see some more interesting part of cylinder. Of a cylinder, slander. Okay. Now this is a cylinder, and this cylinder is being used to roll a cricket pitch. The cylinder is being used to roll a cricket pitch. Hey, कौन बड़बड़ कर रहा है? This cylinder is being used to roll a cricket pitch. Every time I turn the cylinder, one turn. So what happens if you look from the cricket pitch perspective, then the height becomes the breadth of the cricket pitch. Is this understood? And every turn that you make, when you turn it once, then how much has it moved? It has moved 2 pi r h. Is it? No. No, it has just moved 2 pi r. One turn is 2 pi r. One turn is 2 pi r. After this, we move it by another one turn. So it goes another 2 pi r. Then we don't know. So we do some n numbers of 2 pi r. So the n 2 pi r is nothing but the length of the cricket pitch. This is another funda that you should remember. Did you understand this or not? The n 2 pi r will be the length of the cricket pitch. See, end of the day, the cricket pitch has an area which is what? Length into breadth. So my answer should be meter square. Meter. And 2 pi r. Meter. Meter into meter, meter square. If you write this as 2 pi RH, you are already starting with meter square. Meter square into meter, it will become volume. So that is wrong. Every time that you open, when your kite, sometimes they may say, how far is the kite? Every rotation the kite, your thread drum rotates, you're releasing how much of thread? 2 pi r. 2 pi r. 2 pi r. So after 1600 revolutions, how much of wire has gone out? 1600 into 2 pi r. Utna dur tumhara kite hai. Considering that the kite is exactly on a straight line. Stretch kite. No, a problem might come up. Problem might come up that how many rolls of the cylinder will actually roll the pitch. So for those problems, you have to know that. Also, the same problem can be brought for wheels of a bus also, but that comes in angular motion, not here. Right? Now let's see another problem of it. Let us now change our perspective of cricket pitch and let us think that this is a talcum powder container, and this is the label of the container. So if you want the label to be exactly match fit, what is the dimension of the label? The dimension of the label should be, if this is a label, then the dimension of the label should be height into 2 pi r. Sir, where did the n go this time? Are you idiot that you will go on wrapping the label like this? You will wrap it only once. And let's bring more complications out here. They say that 2 centimeter margin has to be left for gluing. So 2 pi r plus another 2. Yeah, your label, exact label is this much. If you wrap it, then it is edge to edge fit. But I am saying leave 2 centimeter margin. That means I have to leave another 2 centimeter margin out here. On this, so how much of length do you want now? 2 pi r plus 2 centimeter. On this, that particular will go and wrap up. So finally you will lose that 2 centimeter again because there will be no overlap also. ठीक है, तो ये सब ध्यान रखने का है. सिलेंडर में यही सब में ट्विस्ट करेगा आपको, इससे ज्यादा ट्विस्टिंग नहीं होता है. Now we'll go to hollow cylinder. Whatever I have bugbugified, have you understood so far? Clear? Let's now go to a hollow cylinder. Hollow. So let's see the hollow cylinder from the top. Always try to have a designer's perspective. Let's see the hollow cylinder from the top. A hollow cylinder from the top will be seen like this. Do you agree? And hollow cylinder, and this much is my material. This much is my material. So this is the thickness. Say this is your wooden flower vase or whatever it is. This is the material. Now here we have to be very careful. Children, what is this? This is known as my thickness T. If you are measuring, and what is children this? This is Ri and this is Ro. If you are measuring thickness with radius, then Ro minus Ri will give you thickness. But if you are doing, Mr. Rajiv Rastogi, if you are, volume, if you are doing it in terms of diameter, then the story changes. This is Di and this is Do. Do minus Di will be always 2T because there is a thickness on this side also. There is a thickness on this side also. समझ में आया ना? हाँ, एकदम पजामे का नारा जैसा है. Tailoring is also interesting. Suppose you say that increase my trouser, I've added more to my body belly, increase my trouser with 2 inch. So on the front side 1 inch, on the back side 1 inch. You can't have 2 inch on one side, नहीं तो तानपुरा का कवर लगेगा वो, है ना? समझ में आया? क्या चीज अत्र कुछ समझ में नहीं आया लग रहा है. हॉलो सिलेंडर मैंने समझ रहे हो? आर पार दिखेगा. हॉलो सिलेंडर विथ थिकनेस. Have you understood? Hollow cylinder with thickness. Pipe जैसा मान लो thickness. So I am now seeing the hollow cylinder from the top. So what will I see? I'll see a circle. Clear? Now here we have to give our role for thickness. So how to see the thickness? If you see by radius, outer radius minus inner radius is thickness. Correct? But if we are playing with diameter, then outer diameter में 2 बार thickness घुस गया है ना? What is, see outer, see Atraya, mutating the diagram, okay? Outer radius means you are attacking the thickness only once. Outer diameter means you are attacking the thickness twice. ठीक है? And inner तो कोई बात नहीं, this is inner diameter. So outer minus inner is actually 2 times of thickness. But outer radius minus inner radius is 1 time thing. Now say suppose this is a wooden cylinder and I want to find out the volume of wood. So इसमें volume क्या है? The volume of the outer cylinder. Let's see the volume of the outer cylinder. The volume of the outer cylinder will be pi Ro square H because the height remains the same or the length is same. Right? So if you see the volume of the outer cylinder contains wood plus air also, but I need only wood. So from here I will subtract inner cylinder, pi Ri square H. Inner cylinder is only air. Wood plus air minus air. So only wood is remaining. So this is the volume of a hollow cylinder. And to make it better, we can write pi H Ro square minus Ri square. And when you solve this calculation, don't be a moron. This is a plus b into an a minus b algebra formation also taking place. So it's a square minus b square. Did you understand? Whoever didn't understand, let me know. I'm trying to find out the volume of a hollow cylinder. So what is the volume of a hollow cylinder? So far we were dealing with solid cylinders. Hollow cylinder means outer cylinder. Outer is material plus air. Inner is only air. So it is like this. Mat plus air minus air. Air cancel. You are left with only mat. You understood? Very good. They were excellent children. So we're done with cylinders. Let's go to our next boy. The cone. Cone. Birthday cap. Any questions on cylinders? Okay. Our next job is cone. Cone. So cone will be a circular base. Okay. Cone is a circular base, and you actually can all find this from, when you study integration, this becomes so interesting how the formulas of cone came up and all. This is a cone. Now think how a cone, how somebody must have made a cone. Take a cylinder and you put it in a lathe machine. You know lathe machine? A machine which will rotate the job. Take a cylinder and fix it on solid wooden cylinder, and you fix it on the lathe machine and let it turn. Boom, this turning. Now take a blade or your chisel and don't make it straight, make it arc and let it follow in this direction. You'll slowly cut out a cone. सोच के देखो. Nonsense. You have cut out it. One part, two part, one part. Therefore, cone is 1/3 of a cylinder. What is cylinder? Pi r square h. So cone is 1/3 pi r square h. एक, दो और बीच में ये अंदर से कट के निकाल दिया. ठीक है? So what will be the volume? अच्छा. Cone has got measurements. First, let us see what are the measurements involved in a cone. A cone will have a height, a radius, and also something known as the slant height. So children, this will be 90 degree. This is my radius. This is my height, and this is my slant height. So grandpa will come here also. Grandpa means Pythagoras. So my slant height is always equal to radius square plus height square, and then a root of it. And the volume of the cone is, a cone is 1/3 of a cylinder. 1/3 pi r square h. Cone has something called curved surface area. Now I can't give you any formula for this. This is pi RL. Curved surface area means if you open the cone. When you open a cone, what do you get? Have you seen the car? Not car exactly. Bus wipers which are on top. And when the bus wiper moves, it will create a shape like this. That is actually the shape of a cone. This will come up. Opening the birthday cap, it will just open like this. Where the bottom portion will be very big, top portion will be very small. In earlier classes, we also used to have one more thing which is to be known as frustum of a cone. Means chop off the cone here. So this is a lampshade. Frustum of a cone. Lampshade. Or a steel glass. What is this called? This is called as frustum. All the clutch plates of vehicles are actually on a conical clutch plate which are on frustum based. But now frustums are not there in your. So in frustum we used to have this problem. Have you seen gone for these parties in clubs where after you do your food you say plate kahan rakhna hai? They'll say plate out there. So out there you'll see one steel big gamla sort of a thing kept. I'm not saying the dustbins. If you go in any puja or any place or other places, our birthday parties, you will see all soil plates are kept on one metallic container. And that metallic container is something like this. Something like this. Have you seen? Yeah. And on this, you go and stack your plate. And our so well behaved children will actually drop the plate here and the meat and the other food on the floor because they will do. So long you are eating that. But when it becomes chatta, then this is a frustum. And here that problem used to come for CBSE. Hanumappa and his wife Jangappa. So that problem used to come other. Hanumappa and Jangappa used to make gulab jamuns. Long gulab jamuns. Kala jam. A kala jam shape is that of a cylinder with spheres. And the vessel used to see, children earlier used to have a vessel used to be frustum of a cone. Frustum calculation is tough. Frustum of a cone, here similar triangles will be, but you don't have all those. So here the chashni will be kept, the caramel will be kept. And then they will say every gulab jamun absorbs 80% of caramel to its volume. And Hanumappa and Jangappa can only fill it up to 80% because after dropping kala jam, the chashni will also go up and it will spill up. So we can make problems very complicated and interesting. So curved surface area is pi r. And children, if you talk about total surface area, then you have to add a circular base to it. So it's a pi r square plus a pi r. And that, like a parrot, you always remember pi r into L plus R. So here again there is a parrot formation. Okay, never forget the parrot. So there is a parrot formation here also. Pi r into L plus R. Cone clear? ये सब grade 9 है. Finished? Now we go to Sapir. Sapir. So our next is Sapir. So I can draw a sphere here. All I can draw is a circle. So sphere is like a globe. Sphere is like a globe. Volume. This is sphere. So the volume of a sphere is 4 by 3 pi r cube. Right? A sphere has no total surface area and it does not have any curved surface area. It's like a football. See, surface area's difference comes if you take the shape in your hand and you consider yourself as blind and you can feel two different surfaces, then it's formation of surface area. If I give you a football in your hand and suppose there is no air vent also slot, how do you know where Adidas is written or not written? All is same. That's why in probability they'll always say ball, because when you put your hand inside you can't get any different shape, right? So here it's only a total surface area, bacha. The total surface area is 4 pi r square. Understood? Then comes the Bhikarika Katura. Oh, Bhikarika Katura. Yes, the Bhikarika Katura. So the sphere has been now opened up. The sphere has been opened up. So now you actually see a circular. So if you see the curved surface area, see the beauty part. This was 4 pi r square. You just chopped it. So this becomes 2 pi r square. And if you see the TSA, then you have to add the bottom lid or top lid also. So it's a pi r square plus a 2 pi r square. So it becomes a 3 pi r square. Right? Another formula which you used to do, tota. So never forget tota. Tota is a measure of your incompetency and the volume should be half of this. So it's 2/3 pi r cube. Have you understood? Sketching class में पढ़ा है, setting मार रहे हो, setting not allowed. Setting is allowed in art classes. ये क्या बना है भाई साहब? Done. Now let's see how. Now we have to do composite shapes. Composite. So before going into chapters, see every problem will be different. So let us now see what all type of composites we can actually. Composites we can think about. The first one. A well is dug. So where do you dig the well from? From the ground, right? So you'll be digging the well in the shape of what? Cylinder. And the earth is kept on the ground nearby. So if this is the ground, then the well is actually getting dug in this manner. Do you agree or not? And the mud is piled up in a heap. What shape will it take up? Cone. So this is one type of problem. Another can be that the mud that has been taken up has now been used to create a ring for this well. अब इस well को ऐसे तो छोड़ नहीं सकते ना, बच्चा गिर जाएगा, dog may fall inside. So we have to protect this well. So how will you protect? You will actually create a ring. Means, how to see? If you see from the top, means if you see the side view, then you have basically created a sort of a ring like this, where they'll tell you that this much is the thickness of the, they'll tell you the thickness, right? So if you see from the top, don't you see, you will see it like this. This is the well entry and this is the ring that you have created around the well. Children, try to have artist impression. This is a well on the ground. Now you have to create whatever mud came out. With that mud, you are creating a ring. Are you understanding? So the mud that came out, how much is the volume of that mud? The volume of that mud is pi r square h. No doubt. And what I will be doing now, I will be spreading that mud. See, this is a hole. I will be spreading it around this so that some sort of height can be created. If I see from the top, I will see something like this. Which may, down you go is the water and this much. Now the question comes, how much of height will I be able to create? Now one thing which is frozen for me is, I know what is the radius of my well. And somebody says, please go for T amount of thickness. How much thickness? T amount of thickness, right? So if you see the area of this mud, what is the area of this mud? Pi r plus t whole square minus pi r square. This is the area of the mud ring. This is area, cross-sectional area. If I cut the well like this, then from top I see it like this. And how much mud did I get? I got only this much mud. So this much cross section, and say the length is some h1 that I can't go for any height. I'll be left with only some mud. So I'm going for h1. This volume must be equal to this volume. Have you understood this logic or not? ये मिट्टी मैंने खोद के निकाला. And with this only I am creating the ring. The ring has a cross-sectional area which is pi r plus t square minus pi r square. And how much height of the ring will it go? Some height h1. After this, I'm done with all my mud. So this should be equal to the mud that I dug out. Right? The same question can be again twisted from you and done in this way, that a rectangular ditch has been dug up. Rectangular ditch. But you should actually read it as a cuboidal ditch. Ditch cannot be rectangular. So when you, in that case, I will have a length, I will have a breadth, I will have a depth now, not height. Itna maine kaat liya. This much mud. And now I am spreading it evenly on another rectangular field. Please understand, very interesting. Original field was L, B, and the depth I went was D. So how much mud did you take out? LBD. LBD. LBD amount of, what did you take out? Mud. But you have now gone and spread it on some other field, which is a L dash and a B dash. How much height can you raise for this field? Let the height raised be H dash, where L dash, B dash and H dash has to be equal to LBD. LBD फिर से एक बार हो जाए, बहुत बढ़िया। सुनिए, I have a field in which I have made a rectangular ditch. Basically, I have cut across a cuboid. So there is a length, Shall I take a new screen? Okay, let's see on a new screen. Okay, so I have made a rectangular ditch. So I have a length, I have a breadth, but children, since this is in 2D, please assume that you have also dug up to some depth D. Got it? Or you think that you are burying somebody, cover खोदे हो किसी का, कितना खोदोगे? LB into D, 6 feet under. So it becomes LBD. LBD मतलब जानते हो तो? You girls don't know what is LBD? Little black dress is called LBD. What nonsense you learn? What party animals will you be? LBD stands for little black dress. ठीक है? LBD. हाँ, मैं अभी याद ध्यान दो. Now this mud, this LBD mud you have taken, and you want to spread it on some cricket pitch, because our pitch is very low. We want to increase its height. The pitch has a length L dash and B dash. See, अनन्या, तो ये मिट्टी लेके इसके ऊपर फेंकना शुरू किया, तो इसका भी तो हाइट बढ़ेगा. Let that height increase be H dash. How did this increase? This L dash, B dash, H dash must be equal to the LBD. This is the mud which you have put there, na? Okay, now more interesting. Besan ka laddu in the shape of a sphere has been made on the kadai. And now I have to make it barfi. So I'll be spreading it over a tray. What will be the thickness of each barfi? So I know the besan ka laddu, that big lump. What is the volume? 4/3 pi r cube. Now let's make it, but can you spread it on one tray? No, we will have many trays, but similar trays, congruent trays. Each tray has got a dimension L dash, B dash. And I want that the height of the basin should be just H dash, basin ki barfi. So after you lay that, what did you make? You made a cuboid whose volume is L dash, B dash, H dash into n number of trays. N number of trays, that is actually the volume of the entire basin ka sphere. बर्फी तो रोम्बस होगा काटने के बाद ना, काटने के बाद. Have you seen namak para? Have you seen your mom or grandma or anybody making namak para? First she will make a paratha, then she will do parallel lines, then oblique parallel lines, then namak para, namak para, namak para, namak para, all goes on a frying. Kitchen is the best place to learn geometry. ये समझ में आया? ये भी concept. ऐसा भी क्वेश्चन हो सकता है. ठीक है, चलिए एक और टाइप क्वेश्चन देखते हैं. We'll need 1 or 2 classes to just see scenarios, then everything will become easy. So this you have understood. So these are problems where earth is dug up, earth is laid. So you know that. Okay, next. An antibiotic capsule has to be designed. Antibiotic capsule has to be designed. So how's an antibiotic capsule is like this? No, it is one sphere and one cylinder. Normal guys will see as 2 hemispheres and 1 cylinder. Legends will see it as 1 sphere and 1 cylinder. See, this is what hemisphere. ऐसा तो होता नहीं ना, टैबलेट इस साइड में छोटा और इस साइड में बड़ा हो जाएगा, गले में लटक के. And this side is also a hemisphere. Legends will see this as 1 sphere and 1 cylinder. Have you understood? Where the radius of this and the radius of this is sun. And what is the total length of the capsule? The length plus. Again, legends will say length plus diameter. Not length plus R. Length plus RR. So the tablet is actually length plus diameter. This can also be said as a bullet of LPG has to be designed for a lorry. Have you seen lorries carry that LPG bullet? So this can be also come as an LPG bullet problem. Understood? Very good. There is a duster on my table. Duster. Duster is used for what, beta? Dusting the board. In our days, it was also used for hitting us. Ma'am used to directly throw the duster on us and you used to save yourself. Sometimes you got hit. Duster. A duster whose felt pad has gone off. The felt pad is gone. And there is a creative DIY boy who now wants to make the duster as his pencil holder. So what does the tip of a pencil look like? Cone. And the cone, he has made impressions here which are like this. समझ में आ रहा है? अच्छा एक चीज बोलो. Let us say the total surface area of this particular duster was A. After making this, he has to drill out this much material he has to throw out. The surface area increases or decreases? Increases, never decreases. How to answer that now? If I was a painter earlier, I used to just paint it pi r square. Now I have to paint that pi r square portion. निकल गया, अंदर में मारना नहीं होगा क्या? It is like cleaning the toilet, man. Have that feeling. So your surface area increases. If you take an apple and you bite it, the surface area has increased. The more the surface area, the easier the combustion. That's why when you take wooden pieces, paper, this big cardboard doesn't burn, but when you tear it, surface area बढ़ गया है ना? ज़्यादा surface area, ज़्यादा. That's why in movies when you see Om Him Krim Chamunda Nama, they do that and boom, blast comes up. You want to do that at your own risk in some campfire? Just take wheat. Wheat is very deadly. Wheat explosion, people have died also. If in wheat go downs, if fire catches, death is ensured. Wheat catches fire very quickly. Have you made fulka rotis and you see the amount of red chingaris which come up? It's all wheat burning. You just take some wheat and you put it into the fire, immediately boom. That is what they do in movie now. Om Him Krim Chamunda. That's wheat. Got this problem? Okay. Another problem can be that a Cadbury's chocolate in the shape of a cuboid has been made into spherical nutties. So here what is the volume? Each nutties will be pi r square 4 by 3 pi r cube into n number of nutties is equal to LBD of a dairy milk. And these problems always considered as if you have used the entire chocolate. कुछ तो लगा रहेगा ना? So in realistic, the problem should be where only 80% of the material can be recovered. Do you agree? You can't eat everything. Everything will be remaining. So we'll keep it till this much. We'll see some more composite problems in our next class, some more complex composite ones. And then like lattu, top. So if you see a top is like cone, and on cone, hemisphere, yes. That